Hi everyone, welcome to today's lesson on significant figures. In this lesson, we are going to learn about significant figures and why they matter in our measurements and calculations. So significant figures are measured or meaningful digits. They are a combination of certain and uncertain digits. So there are about 3 rules that will tell us what digits are going to be significant. So the first rule is that all non-zero digits are significant. So for example, if we took a look at A, we have 1.25 kilograms. So since 1, 2, and 5 are all non-zero digits, that means we have 3 significant figures. Or in short, we often like to say 3 SF. In 3,454 days, 3, 4, 5, and 4, all of those are non-zero digits, and so they are significant. So 4 significant figures. 1725 from 17.25, that's 4 significant figures. And then in 4.2 times 10 to the power 3, we have the 4 and the 2 for 2 significant figures. Keep in mind that the 10 to the power 3, this is part of the exponent, and so this does not count towards significant figures. The second rule is that zeros to the left of a decimal is significant if there is a digit to the left of it. So, for example, in A, here we have a decimal place. We know that the 6 and the 9, they are significant because they're non-zero digits. This 0 here, this is to the left of that decimal. And at the same time, if we take a look at that 0, if you look left to the 0, you see the 9 and then the 6. So this 0 is also significant, which means we have a total of 3 significant figures. For 150, notice that there are no decimal places. So in other words, this rule does not apply to it. This 0 is insignificant. So we only have the 1 and a 5. And so this is 2 significant figures. Then we have 125,900. So we know that 1, 2, 5, and 9, these 4 are significant. The 2 zeros here, because there are no decimal places, so the rules don't apply here. And so there are only 4 significant figures. Rule number 3, zeros to the right of the decimal, they're a little bit more tricky. If there are numbers to the left of the 0, they will count. Otherwise, we're going to ignore them. So if we took a look at A, we have the 5 and the 3. These are non-zero digits, so they count. These zeros here, they are to the right of a decimal. Yet when we look to the left, we eventually see digits, the 3 and the 5. So these zeros will count for a total of 4 significant figures. Okay, B, 0.00053. We know that these 2 digits count. If we take a look at this first 0 here, we'll note that it is to the left of the decimal, and from rule 2, it will only count if there's more numbers to the left of it, which there aren't, so that doesn't count. Then the next 3 zeros here, they're to the right of a decimal. Yet once again, if you take a look to the left, there are no numbers there, so they don't count as well. So there are only 2 significant figures. Okay, this 2 counts, the 5 counts, the 3 counts. If we take a look at these 3 zeros, all 3 of them are to the right of a decimal. Yet when you look left, you do see a number. You see the number 2. So that means these 3 zeros will count for a total of 6 significant figures. In D, we have 89.002. Once again, the 8, the 9, and the 2, they count for these 2 zeros. Let's take a look. Both of them are to the right of a decimal. Yet when you look left from those 2 zeros, you see the 9 and eventually the 8. So these count as well for a total of 5 significant figures. Then we have 0.02089. We know that the 2 counts, the 8 and the 9 counts. If we take a look at this 0 here, this is to the left of the decimal place. And according to rule 2, if we look to the left, there are nothing there, so this doesn't count. This 0 is to the right of the decimal place. Yet when we look left, we see nothing, so that doesn't count. Now this 0 in between the 2 and 8, It's also to the right of the decimal, yet this time when we look to the left, we do see the 2, and so that counts. And so this number here has 4 significant figures. In F, we have 3.40 times 10 to the power of 3. Okay, all 3 counts for a total of 3 significant figures. Once again, just like in example 1, this is an exponent, so it does not count towards significant figures. Now keep in mind, when we're counting numbers, let's change the screen. The numbers that we count with, or things that we count with, we don't use significant rules. Okay, so for example, if I'm trying to count the number of students in a class and I count 30, okay, and then that means there are 30 students in the class. Okay, significant rules do not apply because it is not a measurement. I didn't have to make any guesses. There are no uncertain digits. Okay, that number 30 is a certain number, and so I don't use the significant figures. Now, why we use significant figures, once again, is because we do want to include the certain and the uncertain digits. And a lot of times in labs, with the numbers that we measure or that we obtain, we do calculations with it, either multiplication, division, or subtraction and addition. So if we do multiplication and division with significant figures, the rule says that after multiplying or dividing, we're going to round off the answer to the least number of significant figures contained in the calculation. Okay, so let's take a look at a few examples. If you punch into your calculator 2.4000 divided by 8.000, you will get 0.3. This is what your calculator will tell you. Okay, but if we're doing multiplication or division, we need to look at the question. In question A, 2.4000, this is 1, 2, 3, 4, 5 sig figs. The 8.000, that is 4 sig figs. And so the rules tell us that we're going to round off the answer to the least number of significant figures contained in the calculation. Meaning, when I look at the question, the 8.000 has 4 significant figures, which means my answer is going to need 4 significant figures. Right now, it only has 1 with the 3, so I'm going to put zeros at the back to ensure that it has 4 significant figures. Okay, let's take a look at B. I have 3.14 times 2.000002. If I punch that into the calculator, I get 6.28000628. Okay, a big number with lots of decimal places. If we take a look at the question, 3.14, this is 3 sig figs. This is 1, 2, 3, 4, 5, 6, 7 sig figs. Okay, we're going to round our answer to the least number of sig figs in our calculations, which means I'm only going to round to 3 digits. Okay, so that is going to be 6.28, 3 sig figs. Let's take a look at C. I have 15.55 times 0.012 brackets, and then I'm going to divide. So once again, we can punch this into our calculator. We get 7.585 times 10 to the power of negative 3. Okay, if we look at the question, this has 4 sig figs. This one has 2 sig figs, and this one has 3 sig figs. So we're going to round our answer to the least number of sig figs, which is 2. Okay, so that becomes 7.6 times 10 to the power of negative 3. In D, once again, we can punch this into the calculator, and we're going to get 1.7864 times 10 to the power of negative 4. Looking at the question, this is 3 sig figs, this is 2 sig figs. That means we're going to round our answer to 2 sig figs. So we get 1.8 times 10 to the power of negative 4. In E, same thing. We can put all of that into the calculator. If we do that, we get 113.55. Okay, sig figs. This is 3 sig figs, 1, 2, 3 sig figs, 2 sig figs. Okay, so I'm going to round it to this place here. Okay, now this one's a little bit tricky. There's two ways of expressing that. We can say this is going to be 110. Okay, no decimal places, so that's only 2 sig figs. Or we can also say 1.1 times 10 to the power, move back twice, so 1 to 10 to the power of 2. Okay, so two different ways to showcase 2 sig figs. In F, once again, we can put that into the calculator. We get 2355 0, 0, 0. Okay, let's take a look. I have 3 sig figs, 2 sig figs. I'm going to round to 2 sig figs. So that means this is going to be 2.4 times 10 to the power 6. Okay, so that's multiplying and dividing. When we're doing addition and subtraction with significant figures, the rules are slightly different. This time, after adding and subtracting, we're going to round off the answer to the least number of decimal places contained in the calculation. Okay, so for multiplication and division, we're looking at the least number of significant figures. For addition and subtraction, we're looking at the least number of decimal places. Okay, so in A, if I take 12.56 and I add it to 125.8, okay, I get 138.36. Okay, but if you take a look at the question, 12.56 has 2 decimal places, 125.8 only has 1. So we're going to make sure we only have 1 decimal place. Okay, so this is going to be 138.4. Let's take a look at question B. I have 44.0376 minus 41.037584. We just put into the calculator and we get 3.000016. Okay, let's take a look at the question. This is 1, 2, 3, 4 decimal places. 1, 2, 3, 4, 5, 6 decimal places. So we definitely want to make sure we round our answer to 4. Okay, the least number of decimal places. So this would be 1, 2, 3, 4. In other words, 3.0000. Okay, and C, same thing. We can put into your calculator. We get 12.333. This is 2 decimal places, 1, 2, 3 decimal places. We're going to make sure we round our answer to 2 decimal places, so 12.33. Okay, in E, whoops, I skipped D, but in E, if you add it, you get 2,552.534. Looking at the question, this is 1 decimal places, 3 decimal places, so we're going to choose the lower one, which is 1. So we're going to make sure we only have 1 decimal place. This is going to be 2,552.5. Okay. Now in F, G, H, and I, it's a little bit different. In F, we have 2 parts. We have an addition that we need to do, and then we have a division. Okay, so the way to do this is we don't want to prematurely round our answer in the middle of our calculations, but we do want to keep track of the decimal places or significant figures. So for example, if I take these 3 and I add it up, I get 153.2. Okay, now I know I need to have 1 decimal place because all these have 1 decimal place, and it turns out this number here, 153.2, has 2 decimal places, so I'm fine. When I divide, once again, you're looking at significant figures. In this case, both of them have 4 significant figures. So therefore, my answer is going to be 51.0667. But since I'm rounding to 4 significant figures, this is going to be 51.07. Okay, F, we can do something similar. If I take 42.1 times 0.982, I get 41.3422. Okay, now if I'm looking at this question, since I'm multiplying, I'm looking at significant figures. So there's 3 significant figures in each of those calculations. So I'm just going to keep in my mind and make a note that my number here technically should end at the 3. Okay, now I don't want to just delete the 422 behind. Okay, that's useful in my calculation, and I don't want to restart my calculation for every step. Okay, you want to keep the decimal places, but I use these lines here just to kind of remind myself how many significant figures I'm looking at. Okay, this one here, this is going to be plus 1.74. Okay, now when I look at the question again, 1.45, there are 3 significant figures. The 1.2, there's 2 significant figures. So technically, I'm supposed to end at the 7, the 1.7. Okay, once again, but if I'm doing my math, I don't want to prematurely round. Okay, if I add that up, I get 43 point, let me calculate that. 0.0822. Okay, so that's unrounded answer. Now, if you look back into your question here, I've underlined kind of how many significant figures there are supposed to be. Okay, so when I add, remember I'm only looking at decimal places. So this number 41.3 has 1 decimal place. The 1.74 has 1 decimal place, right? Because this 4 isn't really there. Okay, so that means in my final answer, I need to have 1 decimal place. So this is going to be 43.1. Okay, H works in a similar way. Okay, if I do this, I get 33.0804. Okay, but keep in mind when I'm multiplying, I multiply to my answer rounds to the least number of significant figures. So 1.021 has 4 significant figures, 32.4 has 3 significant figures, which means my answer should technically only be up to here. Okay, let's take a look at the next part. 0.672 times 34.12. This is 22.928. 92864. Okay, and if I add that, I get 56.00904. Okay, now the 0.672 times 34.12, this is 3 sig figs, 4 sig figs. So technically the number should end after the 9. Okay, so when I'm adding, I want to keep that in mind. When I'm adding and looking only at the decimal places, this is 1 decimal place, 1 decimal place, which means our answer will have 1 decimal place. Okay, so our rounded answer is 56.0. For this question here, if you put it into the calculator, okay, you're going to get, let's see, 4.7 times 10 to the power negative 4 minus 3.52 times 10 to the power negative 3. Okay, you get negative 3.05 times 10 to the power of negative 3. Okay, now if you do that, it gets a little bit harder trying to figure out significant figures. So if you're adding or subtracting, it might be easier if you just write out the number that you're using. So 4.7 times 10 to the power of negative 4, this is actually 0.00047, okay, minus 0.00352. Okay, so for the first one, there's 2 significant figures. Okay, it goes all the way to the end of 7, which means all these are going to count if I'm subtracting or adding. Okay, this is going to be 1, 2, 3, 4, 5. Okay, so I have 5 sig figs or 5 decimal places for both. Okay, so let's just check this. This is negative 0.00305. Do I have 5 decimal places? I do, so I know that that answer is correct. As always, please make sure you try the fun sheets and then check your answers with the fun sheets, and then email me if there are any errors or if you have any questions. See you all next time.